Hello, grade 10, Mr. G here, and we are going to be making a video on electric circuit. This time is a question that was taken from also the 2013 question paper. So this was a question 6 from November 2013, 2013 in the Northern Cape province. Okay, this was set A. So we're going to be solving this question. Okay, now this question said the circuit diagram below show a 9-volt battery connected to 3 resistors R1, R2 and R3. Assume that the conductors and batteries in the circuit have negligible resistance. So we have the battery, we have 3 resistors, and there is not internal resistance in either battery or conducting wires. 1.1 define resistance in an electric circuit. 1.2 calculate the total resistance of the circuit. 1.3 compare the magnitudes of the current trends through R1 and R2. Give a reason for your answer. So let's start with the solution. It's a very simple question, and the question 1.1 is definition of resistance. So we say that the resistance is the opposition to electrons to flow through a circuit. That is resistance, and just for control, let's recall that resistance, we use the symbol R and the unit is ohm. The symbol for ohm is Greek letter omega. So this is regarding resistance, but the only question was to define resistance. Now, in the second question, they say calculate the total resistance of the circuit. Now, remember there is not internal resistance here. It's not part of the syllabus for grade 10. So, we have to calculate the total resistance. Now, we need to know that the total resistance of the circuit, remember, we are only working with the external circuit. There's no internal circuit in this specific one. So, the total resistance of the circuit is equal to the addition of the resistors in series plus the equivalent resistance in parallel. In this case here, in this electric circuit, this resistor here is in series with these two here that are in parallel. So you have one resistor in series, which is R1, and 2 resistors in parallel, which is R2 and R3. Now, let's calculate first the resistance in parallel. This one here. Okay. Now this one here is resistors in parallel. How do we calculate the resistance in parallel? We have two options. Option 1, we say that 1 divided by R in parallel is equal to 1 divided by R, in this case is R2, and 1 divided by R3. Note that you have a 1 here on top. Okay, you can see there is R2 and R3. That's why I refer to those. The other option is to say that R parallel is equal to the product of R2, R3 divided by the addition of R2 plus R3. But now this one here, you must be careful because we can only use it for 2 resistors. I'm going to write parallel like in mathematics, okay? So it can only be used for 2 resistors in parallel, while this one here, you can use it for as many as you want, okay? So that is the first one. So we're going to substitute both of them. We're going to add a page here, and we're going to substitute in both of them here. 1 divided by Rp is equal to 1 divided by 2 plus 1 divided by 3. And let's not get confused. So let's do it step by step here. This one here, 1 over Rp, when you solve this side here as it is, you can use your calculator, you will get that the answer is 5 over 6. So guys, all you have to do now, this is not the answer. Now all you have to do is to switch places and set that Rp is equal to 6 over 5 because it is the inverse. We're working with the inverse. All right, so the inverse of that one is going to be 1,2. So R parallel is equal to 1,2 ohm. Okay, so this is for R parallel. It's not the final answer. Now, if we use the other option, we say that RP is equal to R1, R2 times R3, which is 2 multiplied by 3 divided by 2 plus 3. And when you solve this one, you will get 1,2 ohm. So you can either use any of them. This one is very easy. This one is very easy option, but remember, it can only be used when you have 2 resistors. So if you have 3 resistors in parallel, you cannot use that one there. Okay, so let's continue. Now we're looking for the total resistance. So let's not forget that we're looking for R total, which is equal to Rs. I'm going to rewrite the formula just for us not to get lost. Rs is the only resistor in the diagram, and you can see it's 1 ohm. That is R1. So R1 is going to be 1 ohm, and R in parallel is going to be 1,2. So it is going to be 2,2 ohm, and that is the calculation they're asking you in this question. That would be the answer. That one there. Okay, so that is that question using both methods there. Okay, so now the next question, or the last question, is very simple. This question, they say compare the magnitude of the current strength through R1 and R2. Give a reason for your answer. So all you have to say is which one is greater and which one is smaller. Now, in grade 11, we are going to do this one in more details, but you will learn a formula that say I is equal to V over R. So what you need to know, in the parallel circuit here, the one that will have the greater R will have a smaller current. The one that have the smaller R will have the greater current. So in this case, we have 2 and we have 3. So this one that have greater resistance, we have a smaller current. I'm going to write it in symbol. This one that have less resistance, we have a greater current. That is all they say. And now they say explain, which is what we say. The current is inversely proportional to the resistance. So in a parallel circuit, as it is this side here, in this circuit, in this side here, the potential difference is the same. Remember, in a parallel circuit, potential difference is the same. So here, the potential difference, let's write it on this side. Potential difference that go through R2 is going to be equal to the potential difference that is going through R3. So if potential difference is constant, then we can apply this formula here. For V constant, the bigger the R, the smaller the I. The smaller the R, the bigger the I. So I hope you understand, and that's all about this question. It was a really easy question, but it is important question for the upcoming examination. Okay, first of all, definition of resistance. Second of all, calculated total resistance of a circuit in which we have series and parallel, no internal resistance. That will be for upcoming grades. You will learn about the internal resistance, and finally, we don't even have to write that one. We saw it here on the sketch. Okay, you can write it down properly while you answering the question. Okay, so I hope you understand. I hope it helped. Thank you for watching. Thumb up, subscribe for the next video so you don't have to be searching for them, and then I'll see you next time. Good luck. Thank you for watching.